Hello, it's Duncan. I believe that, apart from one wafer-thin bug, our 10-pin bowling code is complete. It passes all its tests and has all the features it needs. In software though, complete rarely means finished. It's a fact of life that because jobs often take longer than we anticipated, we feel pressured to say they're done, even when they're not as polished as we'd like them to be. Even here, where it's my job to personify programming prowess, I feel I should wrap up an episode before you get bored. To counteract this, I find it helpful to return to code once it's working, but after at least a night's sleep. I check that I haven't missed anything with fresh eyes, a sort of personal PR review if you like, but without the ceremony, one-upmanship and soul-sucking delay. I'm going to work from the outside in, just having a look at everything and seeing what could be made better. The first thing then is this constructor here, this invoke for our game. It takes it upon itself to create completed games if we don't have any players or frames. And looking at this, it occurs to me that if our player names is empty, then player names map something will itself end up empty. So I think that this one will do when the player names is empty, and we can just combine them by saying that or that. Run the tests, and we're good. And now I think it would be nicer to use the normal case first. I don't think there's a way to swap a when round, but we can replace a when with an if, and then we can replace the or with an and then we can invert the if condition and then convert back to a when. Is that true? Jolly good, and maybe just lay that out a bit more like that. Okay, next thing, it's a little odd having this invoking the companion object for game, especially as game is an interface. It means that if you look at game in order to understand the API, you are confronted with this thing. We can solve that by adding operator fun game.companion.invoke, and then that we can copy into there. And now we can delete the contents of the companion object. It has to be there at the moment because otherwise we can't reference it. I think there's a proposal to have it sort of automatically declared in any case. But that simplifies the view of our game to our clients, but the function is still there to create a new game. Moving down to PlayableGame, this also has a complicated constructor, and I can't really remember why. It seems to me that PlayableGame is doing an awful lot of work to create a PlayableLine, and maybe PlayableLine should be doing that itself. That means that PlayableGame needs to know about unplayed final frames and unplayed frames, etc. It seems a lot more appropriate for PlayableLine to know about those things, and we can do that if we add a constructor to PlayableLine that does this thing. Refactoring to add constructors isn't a thing that IntelliJ does well, so I think maybe we'll just add this in ourselves. We'll say we have a constructor. We know that we wanted to take a player name and the thing that this has, which is the frame count, which we know is an int. And now PlayableLine can invoke its own constructor with this thing here. So that's those things where it is the player name. And then this would become PlayableLine, it, and frame count, allowing us to get rid of that. Is that true? Good. Let's tighten that up a bit to there. And now I'm a bit suspicious of this require. It's there to check that we don't try and build a playable game with 0 or negative frames. Our constructor function here stops that happening, although not for negative values, unless we call this constructor directly. But we're aiming for code that's as good as we can make it. So let's have a look, see whether we have a test. We have these two checks here for our top level sort of game constructor. Let's add a test to show that we can't create an invalid playable game. So I think we'll just duplicate this into can't create an invalid playable game. So what do we want? We want to expect throws illegal argument exception if we tried to say playable game with either no player names in which case say frame count equals 1, or some player names with a frame count of 0, or a frame count that's negative. Let's just see what does happen. Well, it passes, that's good. Let's see why it passes. Well, partly it's this require frame count is greater than or equal to 1. But looking at what we do after this require, we then call PlayableLine. And this PlayableLine has two things. It has require frames is not empty, and that would take account of frame count being 0. And it also calls this list constructor that takes a frame count, and I'm pretty sure that won't allow a negative number. So I'm going to take a punt and say I think that require is not required. Delete that. And yes, we still pass the tests. Why is it that we fail when we have no players? Well, I guess that's because if a player names is empty, this would be an empty list. That goes into lines here, but we have a require lines is not empty. So our fastidiousness has been working for us. And I think that means we can just take out this unit run now because we don't need a block. And that should be fine. Good. Okay, skipping down this file, current player is unused. Let's remove that. Safe delete. And run. And oh dear IntelliJ, why did you allow me to do that? I think that's a pretty big bug, I'm afraid. So we need to undo. And I note we had the same problem with current player and role, both of which are at least occasionally marked as unused. I wouldn't mind marking them unused, but then allowing me to delete them after I've searched for usages. Dearie me. Anyway, IntelliJ seems to have realized its mistake because the little warning here is gone. We could do something about current line, but to be honest with you, I'm scared of it. David Denton of HTTP 4K fame did have another formulation, and it's sitting as a GitHub PR if you're interested. I don't think completed game could be any simpler. One thing we could do would be to introduce an interface for completed game and completed line. At the moment, when you have one or the other, you can mess with them because they have public constructors and copy methods. I don't think I'm all that worried about that. So I think we'll say games is as good as it needs to be. So we'll commit that with tidy games. Good. And note though, after the commit, IntelliJ has lost its presence of mind again. Ho-hum. Moving on to lines then. Again, we have a sealed interface. It's interesting that PlayableLine and, if I look down, completed line aren't data classes. That I suppose is because we haven't copied PlayableLine here, we've created a new one. Does make me wonder about games. Looking back there, we've used a data class for PlayableGame and completed game, and that's a little inconsistent. Data classes, of course, give us equality and a nice toString. I don't think we're actually using equality by fields in the code at all. And it does kind of beg the question of whether two completed games with the same lines represent the same game or not. I can imagine at least Fred and Barney playing two games where they rolled the same both times, and those games wouldn't have been the same game. If we had more unit tests, I think that PlayableLine and line would more naturally become data classes because we want to compare the return value from roll with data that we created in our tests. I do dislike the inconsistency. Let's see what we did in frames. Well, these are just normal classes in frames. Again, despite the fact that they've got quite a bit of data in them. I think maybe we'll go back to games and say, can we make these not data classes? There and there. And if that passes the test, then I think we'll go with the consistency of not data classes. So I'm just going to amend commit the games, and let's go back to lines. PlayableLine has two constructors. This one we've just created that's used when we are setting up a playable line for the first time, and the main one is used when we are transitioning from one playable line to another playable line. This one is a little bit confusing here. For a start, I think this if is the wrong way around. What we want is a set of unplayed frames followed by an unplayed final frame, and this is backwards for that, so let's just invert that condition like that. It's good. Now, I think there is a nicer formulation of this, which is that this is list of frame count minus 1, where we don't care about the index, but we just add on an unplayed final frame at the end. That would allow us to get rid of the test in here. This would just always be unplayed frame, and we don't need the index, and that's the same thing. We have just traded efficiency for clarity, as this will be allocating the memory for 9 frames and then copying it again as part of this plus. But as we'll only be using this constructor when we set the game up, I think that will be okay. There's an interesting issue here where we're saying frames find it is playable frame as playable frame. Well, evidently we don't need that bit, that's for certain. But it is interesting we need to do this cast. We could get away without the cast if we said filter is instance of playable frame and then just took the first item. Normally I might bulk at this first and want first on null, but in here we are requiring that there is at least one playable frame, so we know this will succeed. Even so, I hate the fact that we're creating a new list here in order to find the first item in it. So I think I'm going to go back to that, even if it is a bit tautological. Do we need the types in here? I don't suppose we need that one. List of frames, quite handy. This is obviously completed frames, and the rest of role is, I think, good. Looking down, completed line is, I think, as simple as we could make it. So we'll check that in with tidy lines. Moving on to frames then. We have a sealed interface of frame and the role 1 and role 2, which are optional. Playable frame that has a role, which takes a pin count and returns the frame. Completed frame is a marker interface so that lines can find completed frames. Unplayed frame, well, that's quite simple. Looking here, we're comparing pin count value with 10. I suppose we'd really like to be able to say just PinCount.equals 10, but going off to pin count, that would require us to override equals. And it turns out that we can't do that yet on a value class. It's a bit of a shame. We could actually override comparable of int and then say if we implement that as return value compared to other, and again go back here, we could say pin count is greater than 9, and I think that would work, but it's not totally satisfactory, so I think we'll just go with the value and 10. Back to bowling, and we can take out the comparable. Here, I'm a little suspicious whether we're actually creating an object or not. It feels like we might want a static pin count of 0. We could find out by tools, Kotlin, show Kotlin bytecode. And here we have total pin count, let's get total pin count. And you can see here that it is iReturn, which I think means it's just returning an int. That suggests that we don't have an object. If we look in unplayed frame and look at its constructor, that's here. It's not clear to me that it's even initializing the pin count, as 0 is the default value for fields. We could test that a bit if we look at strike. Here's strike then, and strike pin count is role 1, and role 1 is a pin count of 10. So let's have a look in the constructor. Here it is, and there is our role 1, and that is also just an I for int. And our init method is going to be somewhere here, and here you can see us pushing a 10 in order to put this integer into role 1. So there's no boxing or creating objects going on there. There is, however, here in get role 1 an interesting thing, which is that here we're returning an object. And the reason is that role 1, it's only pin count here, but in frame, if we look up, it's nullable. And so when we access role 1 or role 2, we have to box them, we have to wrap them in an object in order that object could be null. Okay, let's head on down. So we're happy, I think, with this and this and this. Unplayed frame is similar, if even simpler. In progress frame, likewise, can't see anything wrong with it. Okay, here we have roll1 plus PinCount value. It's a little bit suspicious. Roll1 plus PinCount. Here, when we add a PinCount to another PinCount, we get a score. Well, I think that's okay. We could again add a compare to on our score to save going and getting the value out of it, but I'm not sure that's worthwhile. Moving on down, bonus in progress final frame. This is the one where our total pin count is actually a score. And I suppose is spare might be clearer if it was total pin count.value. That turns out to be okay. In contrast, in normal completed frame here, we have a little bit of a weirdness. Its total pin count, which we might move up for consistency, and the same there, is roll1's value plus roll2's value as a pin count, as opposed to a score. Now we wanted that in order to have pin counts check that its value would be between 0 and 10. And we can't have roll1 plus roll2 evaluating both a pin count here and a score here. We have to choose one or the other, and the one that's going to give us least problems is score, I think. What we could do though is to have, say, roll1 add as pin count, roll2, and then this could be a member function where this is other, this returns the pin count and is pin count of this dot value plus other dot value. Oh dear, looks as if I enter at the wrong time. Did undo get us out of that? Oh well, good. And then maybe, given that one is plus, we could say plus as pin count. And if we go back here, we get roll1 plus as pin count roll2. Just fix that capitalization. And then is spare again is in fact total pin count value. I think it's a bit nicer. And finally, in bonus completed final frame, that is a total pin count is a score. In fact, because roll1 plus roll2 yields a score, then I think we can take this back to roll1 plus roll2, and then we have plus also on a score with a pin count, so that works out like that, which allows us to say is spare is total pin count value equals 10. Ooh, I was over enthusiastic, wasn't I? Because that didn't include roll3. Leads us to the question of whether we should say this is roll1 plus roll2 value, or leave it as it is. But it does point out that in fact we didn't fix the normal completed final frame. Total pin count here can be roll1 plus as pin count roll2, and is spare is total pin count value equals 10. Run. Phew. IntelliJ has a little squiggle under there suggesting it'd like to tell me about something. What does it have? Unplayed frame. I don't think it's a typo. Unplayed final frame likewise. Okay. Interestingly, we seem to have a different rule here than we had down the bottom. That here we are in fact creating a score and then taking out its value. So maybe we should do that down here. If nothing else, it's ever so slightly shorter. Good. Time to commit that with tidy frames. Good, good. And now let's go on to scoring. We had a good go at this last week, splitting out the calculations from the actions. But this frame bonus score for, this is a place where I think we have an extension that really should be a method. So how do we refactor that? Well, what we can do is we can take this thing, cut it out of here, and put it into frame. And what we're going to do is we're going to put it at the top level here, and we need to remove the surplus receiver and make it public. So over where we're calling it in scoring, here, we are now calling this method. And the method is defined to be the same as the previous one, so when we run the tests, everything will be fine. Okay. Now what we're going to do is we're going to take this and we're going to copy it into the places where we have an is check. We have an is check in strike. So we'll take this and we'll go into strike and we'll say in strike we want to override bonus 4. And you see IntelliJ says, well, this is strike. I can simplify that because I know it's true. So I'll simplify that to true. This down here is normal completed frame. That can't be true. I don't think it offers to delete it for us, but we can do that ourselves. Not quite clever enough to know that if this is true, this can never be hit, but we can take that out as well. Oh, well, that really is just rubbing it in, isn't it? Let's put the else back in. And now this when, we can simplify, and it's simplified by removing everything but leaving behind a run. Well, that's really just making a block. I think what we should be is a block body and then taking out this run block here. I don't think it's a thing that can happen automatically. What we really have to do is move the return into here and then delete that and that. So that's how strike implements bonus score 4. Let's go back to frame. And now we know that whenever a frame is a strike, it won't be calling this version, it'll be calling the overridden version. So we can take this one out. Now we'll do the same for normal completed frame. So in normal completed frame, we want to override bonus score 4. And as it says here, that is always true. So get rid of it and then simplify that. And now in this case, we do need to keep the else because we may not be a spare. We could, though, I think, just roll that into there and remove those. Is that true? All good. And now back to frame. Now when we're a normal completed frame, we will be using overridden version, so we can get rid of this. It's interesting that in this case it doesn't offer to get rid of the when for us, but I think we can see ourselves that this is just a score of nothing. I think we might join those together like that and run. Splendid. Returning to scoring, this is now very much simpler. Tempting to wrap bonus score and this frame total pin count into a method on frame, but as that would pull this odd frame total pin count into frame, I don't think I will. What we could do though would be to inline that and then take this expression as a function, which we don't appear to be able to do. Let's undo that. And now I'm going to take this into a variable. No, okay, it seems to be it's having trouble with this operator plus and not able to analyze what that's doing. Let's say val frame score equals bonus score plus this frame total pin count. Do it by hand. This is score plus frame score. Now, can we take this thing into a function? Yes, we can. Now I'm going to take this as a parameter that I'm going to make the receiver. This is a parameter of next frame. This is a parameter of next frame. Inline that. Inline that. Inline that. Make this an expression. And then inline that. Probably pulling this out again as a variable, which is this frame. And adding back in our names. Well, I'm not sure that was worth it, but it is a little bit neater. We can run that. And in fact, would be neater still if we reversed the plus. Except that we don't have an operator for plus to add a score. So back there. commit that with ID scoring, just remembering that the change we made to frames is to make bonus score a method. I still think that might be separate lines. Run all the tests just in case, and commit. Okay, we have one last wafer-thin problem, and I think it's actually a bug. It's pointed out by Yusuf, and that is that we are testing we can't enroll invalid pin counts, but only in the non-final frame. We also need to test that we can't roll invalid pin counts in a non-final frame. Oh, what did I say? This one should be can't roll invalid pin counts in a non-final frame. This one should be cannot roll pin counts in a final frame. So we can make the first frame final by just setting the frame count to 1. And in that case, if we roll a 9, we shouldn't be able to roll a 2 because there's only one pin left to fall. Try running the tests. And they do indeed fail because we are returning a playable game rather than throwing this exception. And worse, there's another case which is quite like this one, where if we roll a strike for our first roll, and then a 9 and a 2, and both of those fail. Let's look at the first one first. This second roll here will be on an in-progress final frame. Note that we are allowing values over 10, but we're not checking what roll 1 was. We're allowing values over 10 because the first frame might have been a strike. So we need to check a bit harder. The question is, should we check a bit harder in roll, or should we check a bit harder in bonus in progress final frame? And I think given where we are, then we should just disqualify creating bonus in progress final frames that are invalid. The only place we actually create them is here, so the effect is the same, but it feels safer to not allow us to create one of these. And so we can write ourselves an init that will require, and it will require, if the first ball wasn't a strike, put the roll 1 in, then roll 1 plus roll 2 can't add up to more than 10. I think it's going to get a bit tacky in here, so let's move this if out of here, and we'll say if the roll 1 value is not 10, then we require that roll 1.value plus roll 2.value is less than or equal to 10, because we might have scored a spare. Is that true? Well, it fixes 1, good. Did it fix the right one? I did, because we've got our strike final frame left. And I think we can go and take this and use it in our bonus completed final frame in a similar way, but here we're going to roll these on 1, as it were. So this is roll 2 value, and this is roll 2 value, and this is roll 3. Put the dot back in there. Is that good? Oh no, we've broken final frame spares, and the reason for that is that we also have to check that we did actually have a strike. So this is roll 1 dot value equals 10, and roll 2 value is not equal to 10. Is that good? Phew. Well, I'm glad about that, although still frankly a little suspicious. But let's lock it down with check invalid rolls in final frame. On the whole, I'm quite pleased with this model, but my lingering suspicions are over its complication. In fact, 10-pin bowling turns out to be quite complicated. We'll get round to some sophisticated testing in the next episode, but just before we go, I think we'll add a test for the only other thing I know about 10-pin bowling, which is the maximum score is 300. So let's create a test, which is maximum score is 300. Now, so far, we have been creating a game object and then rolling on it as a playable game, rolling a playable game, and so on. But we're about to create a game with 10 frames, and that's going to get a bit boring. So, what can we do? Well, we can build a list of the roles that we want to apply. We say val roles is a list, and there are 10 frames plus 2 bonus rolls at the end if we always roll strikes. So that'll be 12. And every one of those we want to be a strike, so that's a big count of 10. Now, how do we get the games that correspond to each one of those rolls? Well, the answer is that it's games is the rolls, and then we can use the running fold that we saw last time. Now we need an initial thing, and that's going to be our game. And we'll just have one player, Fred, and default to our 10 frames. And then this takes a block, and the block takes a current game and one of our rolls. In fact, the roll for this game. And so now, as we did here, we can move the game on with game.roll, this roll. Maybe better to call that PinCount. But as we created game here, rather than playable game, we need to do the cast. So we've got to in here say game as playable game roll. Now, if we've done that, then the type of games is a list of game. So we could now, for example, say games for each println it. And if I run just this test, oh, I'm an idiot, we need to say it to scorecard. And there we have our complete scorecard. And you can see our strikes accumulating until we get to 300. Wonderful. That's given quite a bit of confidence, but I think we can improve things even better by saying expect that. And now we're going to take our games. We're going to take the last of those. We're going to take its lines. And the first of those, because we're only playing Fred, we need to find the scores. And then the last of those scores should be our 300. Now it looks like to scores, that will be in scoring. So that's list of frame to scores is public. Oh, I need to get the frames to scores. And that should be equal to a score of 300. Is it true? Yes, it is. We haven't seen it fail, but it can. When we look at it this way, our pin counts here, in fact, pin count roll effectively, are events happening to our system. And this running fold is accumulating the states of the system. From that perspective, this is like event sourcing. And in fact, when we're event sourcing, we see the state of our system as a fold over the events. Well, that's a highfalutin idea to end on. I think we just comment that out so that we're not bothered by it every time. Commit this with check maximum score. Next episode, we'll look at improving our testing using property-based testing and jQuick. I haven't used jQuick in Anger, so I'm really looking forward to that. If you are too and haven't subscribed, then please do. Also, like this video so that YouTube shows it to other people. And you can fund my work by buying a copy of the book that I opened at price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.